Okay, I promise. This is the last two examples of cigarette smoke that I'm going to show. And part of the reason why is that in the assignment, the way the assignment's listed, it shows this great picture of a render to just show you a real cigarette, which is one of the problems with reference images is that if someone gives you a CG reference for something that's real, that's really not a good reference. It's just kind of like making a copy of a copy, and every time you do that, it deteriorates. And so, it's a great looking picture, but if you wanted to show a reference of real cigarette smoke, you should have real cigarette smoke, as well as maybe a CG version of it. Although the CG version looks pretty cool. We don't know if it's accurate because we don't have a real reference. Anyway, here's two examples of and just as a footnote for that, I create my own video reference, except I can't smoke in my apartment, and it's too cold to go outside and set up a cigarette and get a black card and put it out and shoot some reference just because it's too cold out and I can't smoke in my building, which is a good policy as far as I'm concerned. And so, and I tried looking online for some real cigarette smoke, and you can do that, but it's not exactly like positioned like in this frame. But anyway, so I got two new examples. Both are particle based, but both have a different way of building the smoke shape and both have a similar way of compositing the elements. So I'm gonna scroll through this one, and these are uploaded to YouTube, and they're available on your playlist. So if you want to play it from there, real time. And let me just play through this one first. So this smoke uses something called particle fluid surface, which turns particles into a big shape that we see. And so it's turning into a big geometry surface with a shell on the outside. And I did a couple of renders, and I'm not, as it goes, I still know that this would need more work to do, partly in the compositing area. But one of the things that we see here is that we see the edges are um, more opaque, and so this is the perpendicular to the camera view. So the edges, which are normals, are perpendicular to the camera view, are more opaque, less transparent. Whereas something that's straight on with the camera view is transparent. And um, I was originally looking for a shader, which is commonly called an X-ray shader, that will do this, but then I realized that we can do that without the X-ray shader in just what Houdini provides, but it requires tweaking in composite, which in one way gives us more control. On the other hand, having it done in the shader is also nice because I've done that before, and I would actually prefer that, but this will get it done. Uh, and so as the smoke gets bigger, it's transparent in the middle and opaque on the side. And so we see that. And so this is done with particles. The particles are turned into a big geometry surface, and then that geometry surface is rendered. And as the particles grow or get older or get vertical, the P scale increases, which means the size of the particles, which influences the particle surface operator, which I'll show you. And that gives the larger size toward the top. And then it's composite in all sorts of ways. Let me show you the second one. So this one uses particles, and I'm creating a line from the particles, and then to that I copy stamp another curve shape, which is kind of like a squiggle, almost like an S shaped line curve, and then that's copied to each point, and uh, and that gives us more of a linear thing. And then I had it fade out toward the extreme. So when it gets to the height of the shape, it fades out, and it kind of doesn't work in a way. It curls up a little bit too soon, and so this would look better if the smoke went straight up out of the top rather than bunching up in the top. And so that fading comes from my fading based on the bounding box area, and I'll show you that. So this, like a lot of these things that I do, would be a lot better, if I just keep working on it. And in production for TV commercial for a film, I'm still like maybe halfway toward getting it right, but I got the basic steps, and I worked out earlier a lot of methods that didn't work, which is part of the learning process. And so, you know, if this lesson relates at all to the process of designing effects, is that there can be a lot of trial and error. And and when I worked on TV commercials, boy, we were under the gun. Like the pressure was on to get something done, and a lot of times, work for a TV commercial took, would be done in anywhere from one day to a couple of days to like a long-term TV commercial project would be 3 weeks. Um, and uh, and so, I mean, they could go on longer if they have a huge budget, but there's so much like pressure to get things done really quickly in a TV that working out your method on how you're going to work something, you have to think through things really quickly. You don't have time to sit and look at things over and over and over. So anyway, I got this method. So I've gone through all these different methods, and I wasn't, the reason why I'm showing you these videos is that the other ones were building up to it didn't quite work, and that's part of the process of learning to be an effects artist. And also the other part of the process, which these two files have, is rendering things in separate layers and then putting those layers together. Now, in this example, I rendered one frame high resolution of the ashtray, one frame high resolution of the cigarette, and then I rendered this ash shape changing in in animation for the full frame range. Now you can see where I did that because look at the shadow of the cigarette. The ash is getting smaller, but the shadows stay in the same range. And what I would have to do is render the ashtray or render a separate shadow pass, which I didn't do, which I could have done, should have done, um, and have that match it. And because this isn't, this is still kind of like in a prototype era, and this ashtray would take a long time to render. And these I rendered at full HD 1920 by 1080. Um, and I didn't want to take the time to render that full ashtray. So the quality of the ashtray, one frame is better. Before I was doing it 960 by 480, half of HD. And that got me kind of close at the beginning. And so now the quality is better. The reflections, the shadows, the shape. I zoom in on it, looks better. But I still didn't want to take the time just to get that little shadow moving across. And I could even cheat that with a compositing trick where I could, take part of this block and just animate it over. Um, and by stealing part of the image and scaling part of that image and moving it over, and that would be perfectly legitimate because it looks like the shading is might be similar enough that I could get away with doing that. The trouble is that the gradations in there can fool you, and even though it looks like this blue is the same as that blue, once you scoot a little bit over it, it probably is not. And you can even see there's a little bit of reflection thing going on there. So that's probably not true either. So it could be deceived. But anyway, you could do various things to cheat it, um, and uh, can be legitimate. So anyway, I'm going to explain how I did these two effects, and we're going to start with the uh, this one here first. This one that I'm using this particle fluid surface method. Uh, let's stop that playback. COVID. What? I should have. read that, something about where I am at. Okay, so in this particle fluid surface one, which is M, smoke types, and version 6 is the one that I uploaded for you guys. We're gonna look backwards a little bit. So I'm in the image part, and this is gonna, and I got these L comp 2. Uh, composite, and do I have a newer open? M6 accept. Okay, there we go. Why am I not seeing my frames? One, 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 three. Because he's so. Let's do this. We'll open up and. Okay, so I got this comp smoke, and there we go. There we got my composite showing up. So this is what I'm doing here is true for both of these files that I am going to show you, and my comp is a little bit kind of messy, but I have at the end of these like fingers on a hand. Uh, we have the parts that were rendered, and we'll H over. Okay, so I got these different parts built up for this. And so I got my smoke. So that's the important thing for the smoke. Now the smoke, undo that. I rendered the smoke in 2 layers, and so the 2 layers are important. Um, I rendered one called CD color, and so this is just like a diffuse shader responding to light, and it's got motion blur on it, so we see that blur on there. I may have beefed up the velocity and the blur, which makes it look a little bit too weird, I think, and so that was something I need to check. You can exaggerate the velocity. I think I exaggerated the velocity. Um, but then I did one render that's like a diffuse shader, and then I did another render which uses the normal shader. And the normal shader, looks at the X. It renders a normal in relationship to the camera, I believe, the normal that's calculated for the geometry, and so it gives me a red, a green, and a blue channel. And so the blue channel uh, or the red channel, it gives us this variation in how the shading uh, over the surface. So green, blue. So the blue tends to be giving us the darker edges and the transparent in the side that's facing the camera. So that's one way to do it. So that's using a normal shader. Another way to render these, I'm going to go back here to color. So I'm looking at these different red, green, and blue, and so this one's rendered with a diffuse shader white, so red, green, and blue are all the same color. But I can render in the rendering process, I can render a normal, which looks a little bit like the previous one, kind of. Let's compare that to this, but this normal renders without any shading effect at all, and it gives me a red, it gives me a blue, and gives me a red, green, and a blue. And so these are, it's just rendering the shader. And so this gives us some variation in how the light falls over. One thing you'll notice about this pass is that it doesn't have the motion blur on it that the color channel will have. So that has a motion blur. That doesn't have the motion blur on it. And that obviously can be a problem. I also rendered a position pass, which, and then I rendered a PZ, which is the depth. And the depth is, uh, so uh, it's a pixel depth away from the camera. It's used for motion blur. And sometimes these numbers are so extreme that it's hard to see what it is. But uh, you can render these additional channels. Like the alpha is just the pure alpha shape of the object. And so understanding these basic things is part of being an effects artist because we're giving these separate layers to a compositor. Okay, so uh, and if this is all new to you, which it was all new to me at one time, I'm kind of like seeing it for the first time and I'm going like, I don't understand. And that's normal for this kind of job, and that's why we keep a notebook. And we, in our notebook, we don't only write down things we understand, we write down things that we don't understand. And for me, if there's something I have a question about, like I don't understand it or I need to go back and check it later in my notebook, I'll draw a circle. And sometimes at the end of the day or the next day or later, I'll go through my notebook and look for all the circles, and those are things that I said, well, at one time, whenever I wrote it down, I was like, okay, I wrote this down. I put a circle by it. It means that later on, I'm going to go back and follow up and try to understand it. And th- and so notebook wise, this is something I started to do. I don't know, later in my career. I keep evolving and changing and trying to do things better. I worked on the movie Stealth, and on Stealth, I was a sequence lead, which meant I had to check up on a lot of people getting their stuff done. And there was a lot of things that I had to go back later. So that's when I started the circle thing because I had so many things that I had to go back in and check on later, you know, at the end of the day or at certain times during the day. So I made circles, and then when I checked it out, when I drew like a check mark through the circle. Anyway, blah 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 blah. I keep talking about stuff. Anyway, there's so many things you're going to get exposed to. So what I did with these two renders, the normal render, the normal shader render, and the diffuse shader render, you can see one is responding to light, fading. This one's pure, the same shape. And then I use a layer node to put them together, and I use a multiply. Now, if I put over or under over, one's going to go over the other one. But if I pick multiply, it's just multiplying basically the black and white. So it's multiplying these. If you think of each red, green, and blue, it is 0 to 1. Zeros, multiply something by 0, you're going to get 0. Multiply something by 1, you're going to get 1. So if I multiply that, let's up here, you see it's 0. Up here, there's like ones or close to ones. And so some of these numbers are like zero point 0.3, zero point 0.8, 0.9 for the red, green, and blue channel. You multiply those together, you multiply something by 0, you're going to get 0. Then I did this channel copy thing where I took the color C, red, green, blue, and I told all the red, green, and blue to be the blue channel. So I could have told it to be the green channel. I could have told it to be the red channel. I picked the blue because normal wise, it seemed to give me kind of the shading I want. And what this did is that so now everything is in black and white. So even though I have a red, green, blue picture, each channel is all the same. And so it's basically saying I want all the blue channel, I want the entire object to be the blue channel. And then I use the gamma, which kind of it's a curve to it leaves the white. It leaves pure white, pure white. It leaves pure black. But the gamma moves like the gray point in the middle, kind of as a curve. It kind of brings down the middle. If you go lower than one, it's going to bring down. If you go higher than one, it's going to bring up. Undo that. And so if it took a straight line between 0 and 1, and you bring down the middle, you're going to get this kind of curve that goes up. Uh, and then one problem that I had is that at the beginning, the way that I made my line, this is the cigarette ash, and I wanted the cigarette ash or the smoke to kind of come out from various parts of the ash, and I got this kind of messy stuff. And so I made this other example of putting a black cube over a white square over a black background. So I got white square, pure picture over the black square full frame, and I did an over, and I moved that so that this is close, the top of this is close to where the cigarette smoke. And so I'm basically using this black and white picture to chop out this garbage right here. So I took this black and white picture, and then and so um, this is one picture that is white over black, and then I blurred that and gave me that edge. And then I took this channel copy, we used that before, and now I'm changing the alpha. So alpha channel, uh, so if I go up here to this blur, the picture alpha is completely white over the whole thing. The alpha is a fourth channel if you've never used it before. Alpha is a fourth channel which allows us to put one picture over another picture easily. And the head of Pixar, one of the heads of Pixar, Ed Catmull, won an Academy Award for this back in the day. This is 30 years ago. And it was so new and so significant way of working and thinking that he won an Academy Award. Now we take it for granted every day, but it was so significant in the making of computer-generated pictures, and it allowed digital compositing to happen. And that's the real significant part is that we moved from when I first started working, uh, there was no digital even though I was making images in a computer. Inside a computer, I couldn't layer one picture over the other. We had to output the videotape and then use analog uh, video editing technology to layer one picture over another. And so I had to render an entire animation of this black and white to video, and then the video equipment, all this very expensive, hundreds of thousands of dollars worth of, like to do a layer, I needed three 1-inch machines, and each one of those was about $100,000. Just to make a layer, I needed, plus all the other routing, switching equipment that went along with it, I needed three $100,000 1-inch videotape to do a simple overlayer. Anyway, so alpha channel is real important. So now I use this channel copy to take this black and white picture. So if we look at the red, green, blue, so that picture, I want this shape to become the alpha. Okay, important. And so then I use this channel copy. I got to look at alpha here. And then when I use the channel and I put the red color, okay, I could use red, green, or blue, it doesn't matter. Or I could even put that in there. I could put color into there, but I'll pick red uh, into the alpha. So now that's what it means is that image-wise, this is all like There's no data there. And then I can put layer. And so another node I'm using here is called outside. And what outside will do is that it's going to take that shape of that square, which is right here where I'm drawing my mouse, and it's going to give me what is outside of that alpha channel shape. So if I click this off here, you can see just by clicking the bypasser, you can see that little part turn on and off, on, off, on, off. Okay, so the shape of that square right there, it's going to give me what is outside of that area. So that's what outside, a lot of times in compositing, I use these overs, and I use over a lot. And then that uses the alpha to layer one over the other. So now I'm using outside. And that's giving me, and so that's a way for me to chop off that little garbage on there. So when I have my animation play, I don't get that extra garbage. Okay, that's one part. And let's look at the cigarette part. Okay, so red, green, blue. So now I have my ashtray. There's no smoke, and it's just this burning thing on here. And so I rendered an ashtray, or this is the background with the shadow. It's not moving. One picture, it's still, and the still part's important because I don't want to render this picture over and over and over again if it's all going to look exactly the same. So I'm worried about time. Okay, so we're going to look at this other part. So this is the ashtray, and I rendered these at high resolution, so I don't need the scale. The scale just makes sure that it's at high res, and if it's already that resolution, it's not going to change it. So this is kind of redundant. Okay, and for my ashtray, I have two parts. I've got the cigarette, and the cigarette didn't change, and then the ashtray didn't change. And I rendered both of those as a single uh, separate frames, and I use the over. And so remember when I was talking about alpha? So the cigarette, when I rendered it, has that alpha. And that alpha is used by this over to put one over the other so that I get that look. And when I rendered one, I had to cut out, you can see it's got a cutout. So that's the matte cutout of the shape of the ashtray getting cut out of the render. And you see this blue reflection, blue highlight that's on the bottom of the cigarette. This is the shadow part of the cigarette, but this is the bounce light from the blue ashtray kind of lighting up the bottom of the cigarette. And that's from the uh, physical based rendering, which helps uh, capture what happens in real light of like light kind of bouncing around the screen. And in my career, this is still fairly new. Even in the 20 years ago was the first time I saw it really used, and it took forever and ever to render. And part of it, the math got better, but the biggest part was that computers got faster. And so this kind of physical based rendering of having this bounce light, now it's a normal, and now it really makes things look, it really is critical for making things look real. And then the Arnold renderer was the first big commercial renderer to use this. And the first movie that was used on was something about a haunted house cartoon movie that Sony Imageworks did. Forget the name of the movie. Anyway, so that's important. But anyway, I rendered those two separate, put them together. Scale wasn't necessary, and that gets combined with the ash. And so the ash I did as two separate renders. I did a red glow. I brightened it, and then I did some color correction. I adjusted the hue, and then I multiplied that together with. I got the ash, and then I did a brightness to that, and then I added those pictures together. Now, you see, when I did that brightness thing, it gave me this big, it brightened the background too, which looks pretty ugly. My alpha is still clean, but so I did a contrast on it, and that contrasted everything. my alpha wasn't clean. But then I did this pre-multiply. And then what the pre-multiply did was the pre-multiply multiplied the entire image by this. So it's basically taking the alpha and multiplying the red, green, and blue by the alpha, and that gives me this nice clean picture again. So and I actually used the pre-multiply in the wrong place. I should have used it upstream. It works here, but it wasn't the super correct way to do it. But anyway, so now I got this shape, and I put that. I'm looking at the red channel. So I put that, I put this over this, and then I get that. Okay. And as I said before, the ash is getting smaller. So that's why I render the ash by itself. Took less time to render these parts as an entire animation than it would be to render the entire thing. And to get the shadow to work, I could still have one frame of the ashtray, but I'd have to render the shadow separate as a shadow pass. And then for a final, I would definitely do that. For this stage in the process, I'm still trying to work it out. Uh, I didn't want to spend the time. And then I put that over the background picture. And then I combine that with the smoke. And then I get this picture. And so a lot of stuff going on here. Um, the important thing for you as a beginner effects artist is to realize that this is how we work. We kind of design an entire effect, but we have to combine it together with everything else. Now, in film production or commercial production, you may have a cigarette that's a real cigarette sitting on a real ashtray, and all we have to do is add the smoke. And so all the background stuff's going to be provided by photography. We just have to do the smoke part. And a lot of times that's what's happened is that they shoot something in the scene and they don't want to have like the cigarettes burning all the time because the smoke's going to be a different place in every cut. And uh, but anyway, this is just gives consistency to it. Like I said, I'm still not happy with the shape of the smoke. And basically, it's just adjusting the speed of the particles is probably all I need to do is to do that. But so the takeaway is that we can have all these different separate elements, render them, and then put them together. And the reason why we do them as separate elements is to save time. And so you can say, well, look at all the time I wasted making all these things together. And like rendering the background is the biggest killer of time. If I rendered this entire scene complete all the way through, it would take a lot longer. And then if I wanted to change anything, which is probably the paramount important, like if I wanted to that color, remember, of the cigarette, I changed that color from red to kind of a yellow. And then when I combined it with the other one that had some red in it, I get this blending of yellow and red, which looks more like a real cigarette burning. But if I wanted to change that, I just want to render that one part over again or just adjust it in the composite and not re-render everything together. So um, and one thing that you'll notice it different from the previous attempts that I made is that the cigarette emission point now is closer to the burning fire, whereas before I had the smoke come out from the entire shape of the ash. Now it comes over of just this area where it's kind of like red hot. So it's limited to that smaller area. Um, and so this is true for this file. This is also true for the other file. And so there was no need to show uh, this process. So in the other one, the particle fluid, the smoke's going to be different. So this is the important part about this lesson I'm showing you is breaking things down into separate layers. Now I did upload this file to the directory where you guys can access Find My Common Files. Now let's look at the 3D part. So we're going to kind of go back to what I did to make this. So I'm going to go to Scene View. And um, and I'm not seeing anything. Okay, so it's trying to run the simulation again. So I got my ashtray. Let me turn off the parts here. I don't need the backdrop. I don't need the table. Turn that off. I don't need the ashtray. And I got two ashtrays on there. One which uses the mat in the render. And so I got two ashtrays. They look identical, and part of the reason for that is my output when I rendered. When I rendered the cigarette objects, you can't use the same object. So the phantom object was the one that gave me that blue glow on the bottom of the cigarette, which is like the light reflecting off the ashtray, and that's from the phantom. And for the mat is the one that cut the ashtray out of the cigarette, so I could composite one over the other. And Houdini doesn't allow us to use the same object for both of those, and so they're basically duplicates. They're both of the same thing, same exact thing, just with different names. And so that allowed me in the render to use them. So even though it wouldn't allow me to use the same name, but it allows me to use basically the same thing. But this is the way it works. And then when I rendered the cigarette, I rendered the paper part of the cigarette, which is the middle part, and I rendered the filter. So let's go back. And so that's the filter. You see the filter turned on and off. And then the paper of the cigarette turned on and off. There, it's right there. And then I got the ash. And then I had this other bounding box shape that's defines. And then I got my smoke surface. Oops. Okay, so this is my smoke. And then, oh, and the smoke has got that line in it. This is that extra garbage part that when I did this, I would definitely want to do it over again. It's going over way too far. I wanted the cigarette smoke to emit from just this part, but it picked the whole shape, and so that's why I had to use that mat to kind of in the compositing that square to cut out this part of the render because I created it, I rendered it, didn't like it, didn't want to render over again, um, but I could do the composite and mat it out really quickly. So my smoke. Uh, and I have two renders here, and the geometry is exactly the same. It's just I'm using two different shaders. This one I use a shader called Show Normal, and that renders just the normal. It renders a red, green, and blue channel as the normal of the surface of the geometry, which is the direction that the geometry is facing. Renders it as red, green, blue. That's about normals, and if you want to learn more about normals, um, you can learn about it in Houdini. You can learn about it by Googling, render normals as RGB at Google. So that's a thing to learn about later. So and then this one here, exact same geometry. I'm using basically I'm using this principal shader, but the principal shader is basically just giving me a diffuse render, like a basic black and white rubber ball, no highlights or anything on it. And then if I go into one of these, so one of these I did all this work. The other one, which is identical, just looks in the other object and it looks at the render me. And the only thing it does is that it attaches that shader, show normal. So if I go in here, click on my object, and then I have to have this transform show into this object. You have to have that there. But anyway, I click on that arrow, it takes me. So this is where that came from. And it automatically yellow selected down on the bottom the out render beam. So now my particle simulation is where, okay, so here is where my particles come from. And then I wrote those out to disk. So I did my particle animation, wrote my particles out to disk, and I bring my particles back. And when my particles come back, they're still they're we can still call them particles, but I can't like add a wind to them and blow them. I can't manipulate them like they're particles. I'm basically pulling back geometry that's written to disk frame by frame. And so now it's particles because it came from particles. It has all the particle attributes that go with those of the particles, but I can't treat them like particles. Like I can't blow them. I can't make them collide with something like that. They're kind of like frozen geometry moving in space, each one individual frame by frame. Uh, and my particles are actually from this node, the auto dop. And so if this is importing it from the dop, and the dynamics part of Houdini is where the particles are created. So I'm going to rewind to frame one because it's going to try to process it. I click on the lower one dop node. Network is the overall network. Node is where they're coming from, and I'll pick that. And so that took me to this particle network. Now if I play this, so this is what's making the particles. And the top right node here, it even gives me the name. This is, and it adds this source on the end. So this is the name of the object that it came from, top level, and then it add that source onto the name. And so if I go to the source tab, so this is where the object came from. And if I want to look where of the object it came from, I click on this. And then I got this node here. It became yellow. So it automatically made that yellow. And this is where my particles come from. And so I have this object here. And then I put in a gradated color. I added a bounding box. And then I promoted an attribute. And then I deleted. I need to get rid of that flag. Okay. And so hit space G. Okay. So basically, I use that color, the breakup, to create this geometry that's moving. So my particles are being emitted from these sets of surface. So here where it's yellow, so when it goes to the dot network, that's what gets used as the emission for the particles. So I'm only going to have particles come from that shape. Now my renderer, I want something different. I want that ash look. And then, so even though this is bigger, because the fire is at this end, I only wanted the smoke come from where it's close to the fire. I didn't want it to come from the entire set of ash, because this is going to generate more smoke than this other part here. It's growing colder. And so to the render, when I render to disk, uh, so I get this red ramp. I combine the two together, and I get this red. So this gets rendered as the ash, but this part here goes to the particles. And so I'm going to go back to my dot network. And because I hit the back arrow and I'm on frame, it generated the whole particle simulation, which in this case didn't take a lot longer. Now, one of the things I had to do for lighting is I had to make the particles kind of blow back a little bit so that the light would always be hitting these early particles. At first, when I did it, the particles went straight up like the smoke. Um, this was going into the shadow and it just wasn't looking right in my render. So I kind of did the fool the eye because from the camera's point of view, it looks like it's going straight up, but in reality, it's going straight back. Now, to improve my render, I really need to have it grow up a little bit more before it spreads out. And so that would be my next iteration if I did that, which I'm not going to do. And so to get that pushback, I use this force. And the force has two parts to it. One is this straight force here that has a little bit of a negative number. Now, a force keeps applying more force. It's like go faster every frame. So these particles are starting off with one speed, which you could call velocity, and the velocity keeps increasing. So it keeps going faster and faster. That's called acceleration. So if acceleration is zero, it's like the car's moving at 60 miles an hour. Its speed isn't changing, so the acceleration is zero. If you hit the brake and you press your foot on the brake, the acceleration goes down, the car gets slower. If you push down on the gas, the car goes faster, the acceleration increases. But the velocity change, um, so the velocity will change, and so velocity is the speed. It's the speed. Acceleration is the change in speed, and uh, it's kind of basic physics. And so if you're interested um, in learning more about this, check out a basics physics class. There's an excellent book called Cartoon Guide to Physics, and it's fantastic by Larry Gonig, the Cartoon Guide to Physics. And um, this book is almost like this, like a Houdini project book. It's fun cartoons, but the physics is really good. Physics is really useful for a Houdini artist, and so I highly recommend it. Houdini should be sold with the Cartoon Guide to Physics. And you can go through the Cartoon Guide to Physics and find Houdini projects to invent. So anyway, that force does one thing. One thing it pushes it back. The second one down below here in the noise tab is that it's adding this swirl, which kind of like the overall motion. And then there's a turbulence, which kind of breaks up the particles moving. So one is a swirl that gives us that big, broad changing of the particles. And then the turbulence is just kind of like a jittering of the particles moving around. And because it's affecting it every frame, uh, uh, as it moves and grows, those forces, those three forces, one is the pushback, one is the swirl, the third is the turbulence. They're all kind of working together to move these particles. And boy, you could spend days tweaking these, which essentially I kind of did. I spent quite a bit of time doing it. One thing that helps is working to scale. If you're always working to scale and like a real cigarette size, I know how smoke like this should work. So the cigarette smoke, similar to steam off of a coffee or other things that are like a small uh, candle smoke, something like that. That size is all related. So if I'm always working to scale, then manipulating these numbers, you kind of get a feeling for it, like, oh, it should be that, it should be that, it should be that, and partly it could be because you know, one thing that I would do is I was just beginning is I would copy that, print this page out and put it in my notebook. Maybe I'd print out this entire page, show my network, and show these settings that what I wanted my force to be set to for cigarette smoke at this scale. And then later on when I had to do coffee, I'm like, well, my cigarette smoke was similar to the coffee steam. It's going to be a little bit different, but, similar. This could give me a starting point for that. Uh, Another reason why notebook's important, and another reason why working to scale is important. So, and then I turned off gravity because I didn't want gravity. If I turn gravity on, everything's gonna get pulled down, and we don't need that kind of trouble in my life. Okay, uh, and so, and then I have a pop drag or pop interact. And pop interact is that if two particles get too close together, um, they will want to push apart from each other. And at the beginning, I didn't want them to push apart. I only want them to push apart. So this gives me kind of another big push. If I don't have the interact on, we just turn it off. Then I play this, and maybe this is better. Who knows? It just a lot of that motion is coming from the turbulence. But the interact gives me an additional little, like, if particles are too close together, it will spread. And I have these numbers set to be really small. And but then I multiplied it. And remember, multiplying something by zero gives you zero, and then by one gives you one. And so the n age is an attribute when a particle is created. it gives me, it's called a normalized age, which means when a particle is born, the value is 0. When the particle dies, the value is 1. And so it doesn't matter how long the particle lives. It can live to be 1 second long. It can live to be 100 seconds long. The normalized age at the beginning is always going to be 0. The when it dies is always going to be 1. So that's a useful number because it's kind of like relative to the life of the particle. And so uh, uh, and so it's important, like, how long are these particles going to live? And if the particles live to be 100 seconds, boy, the normalized age could be harder to tweak because, the anyway, you have to think about that. And so this is getting into kind of advanced things, and it just comes with experience. And I know that some of you, all of you, are going to get overloaded by this, but I'm just making you aware of these are things that we have to think about, and they come through repetition and experience. So anyway, normalized age is the life of a particle, and this is definitely something you want to write on your notebook. And I scaled it by 2. If I scaled it by 4, they would begin to separate faster. If I multiply by 10, they're going to be able to separate even faster. And then this area of radius and fall off is that if the particles are certain distance, are not going to affect each other at all. So this is kind of like how far away the particles have to be from each other. And because we're working in real world scale, if I have a 1 in here, like 1.0, that's 1 meter. If I have 0.1, that's 10 centimeters. 0.01, that's 1 millimeter. So this is 2.5 millimeters. So if the particles are closer than 2.5 millimeters to each other, it's not gonna let them get that flash. So if I increase those, they're gonna push further away. So it's really not having a lot of effect, just a little effect. And then I have drag on here, and the drag, it says air resistance is the variable that we can change, um, and it's also got this wind thing in there, but air resistance. So it's basically like when something moves, it's going to kind of stop it. Like the air is going to resist it, so it's dragging. And so the particles begin to slow down. If I put 10 in there, so the particles are going to slow down even faster. If I put 100 in there, and sometimes we don't see the effect until we rewind. You see the particles are slowing down real quickly, and eventually they're going to come to they might come to a full stop, except I got those other forces that are keep pushing on it. So it's kind of like drag versus these other forces. These other forces are trying to keep everything moving, but the drag is trying to slow everything down. And so I got both, speed and it's just like driving a car. Like if you've ever driven a car in a windstorm and you're driving your car toward the wind, um, you have to use a lot more gasoline or yeah, basically you have to use your engine needs to run a lot faster and you need to burn a lot more gasoline and push your car faster into the wind because the wind is pushing back on you. And one time I drove a Tacoma four-wheel drive truck pulling a U-Haul. So it was a truck with a topper on the back full of stuff and a U-Haul, and through western Arizona, eastern Colorado on Interstate 10, and desert out there. It was really windy, and um, I burned through like an entire tank of gas in less than 100 miles. Uh, because I'm pulling this truck, which is kind of heavy, loaded down, straight into the wind, and I wanted to not go off the road, and I wanted to have traction, so I put it in four-wheel drive, which is going to eat up gasoline anyway. Um, and why am I telling you about that story? Anyway, I had to use a lot of force to move that uh, truck, and the indication of how much force I was using was how much money I had to spend on my gasoline because it was expensive. Let me undo my drag. Okay, back to 1. Okay, so now when I rewind, it'll go like that. So practically the physics affected my budget for driving. So fortunately, I only had to drive like that for a few hours, but the few hours cost me a lot of money. Um, and I pro and because that was a head straight in wind I was driving through, and so it relates to it. Houdini, real world experience really too. So that's my dot network. I'm going to go back to my particle thing. So my particles now are being read in from disk. I can go backwards, which I can't do in a dot net because I'm using this file node. And then I deleted some and deleted the IDs less than a certain. So it's basically particle, the very first particle, ID less than one equal to one. So the first particle is deleted. And then I have this wrangle node, and that adds a p-scale value, which is the size of the particle. And I increase the velocity, which I think I increased too much. And we don't see it, but we see it when it renders. And so the velocity is the speed of the moving particle. And I should have probably left this at 1, and then my render would be better. And if there's anything that I should change about my render, it should probably just be this. And this alone might be worth re-rendering the project for, because it's getting that over blur, okay, and it's just not looking correct. Um, but the p scale is an important size, and so the p scale uses the particle age 0 to 1, and then I multiplied it by itself. I could have used a power function, like 2 times 2 is 4, right? 4 times 4 is 16. And so it increases the part as the particle gets older, it has an even more effect, which basically makes the spheres get bigger faster. And then I multiplied that times zero point 0.5, which kind of says the scale. And then I added 0.01, which means that the particles are never going to be smaller than 1 millimeter. Okay, we have meter, 10 centimeters, 1 centimeter, one is 1 millimeter. So basically, the particles are never going to be smaller than 1 millimeter. So if you think about the size of a cigarette, and 1 millimeter is pretty small. So that's the smallest the smoke will ever be right at the beginning. And because it's based on age, it's going to be really small, going to get bigger, faster. And then this 0.05 kind of controls the absolute size of how big they get. And then I got the velocity, which I should change. And then I did this sort thing. Now I wanted some particles at the beginning, which I think ended up being a mistake. So I wanted these particles to like emit smoke from the basic cigarette. And I ended up really not using it. So if I were to do this again, I would go straight to, I would chop out this merge part. And I had to do some things to make it think it was a particle. So I had to add in p-scale, and I had to add in a fake ID number. Um, and uh, and I wish I wouldn't have done that now. So I should have gone just straight from here to there. So if I were to redo this, so let me do this right minus, and I'm not going to give you this file, but this would be if I rendered it again. So now it's 7 instead of 6, or 4, 4 instead of 3. So I'm going to go straight to this add, and I'm going to make this line. So now it makes a line out of my animation. And the wrangle, I'm going to get rid of that 4 and put in 1. So I'm going to get natural motion blur. Okay. And so this is going to go away, and I'm going to make this, I'm going to do two things. I'm going to bypass it, and I'm going to hit that color key and make it a dark color. It's my way of like, okay, I did that before, and that's what I did, but I'm not using it. So I made a line out of all this. I converted that line to a NURBS, which gives me this more of a flowing curve. And then that only gives me so many points. Then I converted it back to a polyline, which has got a lot of points in it. This is basically like a real curve, a NURBS curve. It says curves NURB. I converted that back into a polyline. And polyline is basically a bunch of short, straight lines connected together from point to point. Um, and I did this polyframe, which adds a normal, and polyframe is a node, and the default is these are reverse. The normal name is n, and the tangent name is tangent. And if you reverse them by hand, do that, you can get something that's called flow normals. And so you can see here the normal of the point is going with the direction of the curve. And so it's adding a normal, and the normal is basically the curve. And my normal is really big. I hit the D key, go to guides, normal scaling, I gotta make that 1/10 of that, and hit the D key. Okay, so now it's smaller. So we can see that this normal curve now is going along the direction. And basically it looks at one point and then the next point and determines the angle, or like averages the angle in between. So I get this normal flowing along, which is important because when I copy something to that, I want that copy to face the direction of that normal. So I have this curve here, that shape, and and the shape is kind of changing with each copy. But when that shape gets copied to the geometry, let me turn off the normal, then it's facing, you can see it's facing the direction of the curve. So as the curve moves, it goes around. So I needed this normal on this line to get the direction of it copying to be correct. And you can see it gets a little bit bigger, from the beginning. It's smaller at the beginning and it gets larger toward the end. And that comes from, I had to have this attributes, inherit attribute stamping. So I did this stamping and I got this twist on here. Now the size of the thing, the size of it getting bigger is coming from the P scale. So remember I made a P scale earlier? Um, and that P scale is adjusting the size of this line. So remember I said it scaled the particles? Well, it's kind of scaling it. And so if I made the P scale larger, if I change that math a little bit, I could get this to be bigger toward the end. And then I have this surface, and so I wanted to render this. This is just a bunch of lines right now. Oh, a twist. I got a twist in here. So I used a twist node here. And you have to look up how to use the twist node because it's got a little bit of setup to it. But basically, I stamped the amount of twists. So I didn't want it to be perfectly identical shape. So with each copy of that curve, it twists it a little bit, so there's some variation in it. And it's subtle, but it's enough to make it not look static. So then when I got that geometry, let me turn off the point number. The normals are turned off. Then I skinned it and I turned that into a renderable surface. So now this is renderable. And um, and if I made the curve more complex and I did like more bending, twisting to it, I could get a cooler variation. Um, and then I converted that geometry to a converted, and that just kind of cleaned it up a little bit. And then I clipped, and the clipping is, I wanted to make sure that it didn't get too tall, and I probably could have raised it a little bit. It sets up a top value for it, and that's something I'm not super happy with. I might have wanted to change that. Clip a little bit higher. So this is like the peak of and that'll help my composite to be. It's pretty sensitive. So that's basically the top of the geometry. And from the camera's point of view, it's the height. Okay. And And then I added a facet, and all I did was do post-compute normals just to make sure that the normals are all facing in the correct direction. So when it renders the curved surface, the curves are basically cleans up the curves. And you can see that there's some weirdness in the normals. So when I have it turned off, it looks different. When I clean it up, it actually looks better. And then I added an opacity, and the opacity is based on the height of it. It means is that it gets more transparent or more opaque the higher it gets. And then that goes, and this opacity attribute gets passed to my shader. So my shader has to have this opacity attribute. And in this case, the opacity is is one number. It's not a red, green, and blue. A lot of times opacity is red, green, and blue. This time this is the multiplier that multiplies the red, green, and blue in the shader. And different shaders are all written different, so you have to look at what the shader did. And let's go look at that really quick. So I'm going to go up, and I go to my object, which is not that one, this one here. And this is that's my show normal. Okay. So this shader, principal shader, CD, it it has a surface, which is the basic surface opacity, has this opacity scale. And you can see on the second line it says parameter OPAC. That's what I'm multiplying. And so the cool thing is that I'm not adjusting the slider here. I'm telling Houdini to adjust this slider. Um, and it's doing it per point in the geometry. And so basically I'm animating every point separately with the opacity for the shader um, at the render time. And so it's really dynamic, and it's animating, and so it's almost like I've got a slider for every point in the geometry constantly moving as the geometry changes. But I don't do that. I let Houdini do that. Part of the power of Houdini. Now remember I told you that opacity in a lot of shaders doesn't have this. It has red, green, and blue, and the name of that attribute is called OPAC color, and then there's a RG and a B. And so if I wanted to manipulate that in my shader, I'd put in opacity color. I'd leave off the RGB, but I need to, let me go back and show you just to overload you. So in this, so if I use opacity shader, um, I would have to have a size of 3, and then red, green, and blue. And then red, green, and blue would all have to be the same. This would be red, this would be green, this would be blue. Um, we don't have to do that. Okay, so now I'm going to go up level. So this is how I created this guy. And this one is getting to be closer to the reference that was provided, um, that was given to you. So I'm going to save this file. And this is a version up. And I'm tempted to re-render it, but I guess I hope I won't. I want to be done with this. I'm going to open up, so that we were looking at N, I want to look at M. So M is the one that uses the particle fluid service. So a lot of the things that we already talked about are going to be true in this new file. And so this one is the one that creates it as a big puff. So I have the particles that go up. So I'm going to rewind here. It's doing a lot of calculation. So I'm going to go into my autodot network, which is my particles. And if I play, so this one I got a lot of particles coming up, and the particles are influencing the shape. And you can see that at the top is not an awful lot wider than it is at the bottom. And so, but basically I just have all these particles come up. There's more particles on the left side than there are on the right side. So these emit some particles, but the left side emits more because the geometry is more dense on that side. Okay, and as we go up, I also did kind of a pushback where it pushes back. I'm kind of looking at it from the side now. So as it goes up, the particles are pushing back, and that's so the light can go. If I had to go straight up, everything down below is going to be in a shadow. And I didn't want to angle the light so crazy from the front. So I just push the particles back, and that just helps the lighting still look like it's from the top, but affecting below. And I'm going to say about that operator. And then, um, and because I stopped at another frame, it's going to do all this processing. That's one of the things about working with dynamics you have to be careful with. So I'm going to go back here. So now this particle fluid source, this is the part that creates the shape. And the more particles that I have in there, the longer it takes. And this one is worth some study on your own. And you see, I don't have an awful lot of notes, but um, I'm importing the particles, and I wrote them to disk, and then I read the particles that I wrote back to disk. So these particles are different from the other one. Um, and I did attribute wrangle, and in this one I did a multiply the velocity. Shame on me, and I did this p scale, and my p scale is a little bit different. This is a smaller number than the other one, so um, or I can't remember smaller or larger, but it's different, and then it sets a minimum size. And then and then so if I look at this guy, I got my particles, and my particles now have the p scale, and this p scale value is going to get used in here, and that determines how big it is. And so it took all those particles that we looked at. It took those particles, treated them like a whole bunch of spheres, and the bigger the sphere is, which is the p scale, the bigger the shape is. So that's where that big shape comes from. So even though particles are all the same size or relatively moving up, the each particle scale is smaller at the bottom at the beginning, and then as they get older, as the normalized age increases, um, we get that. Now the particles never die; they live long enough. I think I set them to 10 seconds or something. Default is 100, which is too high. But I didn't want any of the particles to die, because if the particles die, they start popping off, and so the shape would like flicker, and I didn't want that to happen. And then I took this particle, and so this particle fluid surface, you can see I got all this tweaking going on in here, these bold up here, these three bold ones. And it has to do with the resolution. And this is also another, which kind of sets the detail from this. You can see it's created all this dense polygon surface. And that has to do with how far the particles are apart, which is particle separation. And this is a scale size for each one, and it influence. And so these I had to tweak with a lot. This is I probably spent the most time tweaking these three numbers, and just to try to get that shape to look good. And then I took that and added a smooth operator. That'd make a great title for a song. And the smoothing uh, didn't really do a lot. And so I probably could have got away without that one. Okay, and then I did a peak, and peak can do something funky. So the peak was useful. So the peak, um, I really subtle, and this is another case where experience is that how much do these numbers get tweaked? So if I tweak this a lot, I get big puffy smoke, but it increases even the bottom, so it increases everything. So it made big, big, big puffy. Now if I go negative, peak will make it smaller, and and here's a case where like small numbers are important. But at the beginning, if I get too small, it's gonna like chop that line. It's gonna actually turn it inside out. But up here, if the peak goes negative, you can see that the shape ends up looking more. monstrous or spiky, which could be, useful for a lot of things, but everything that here that went below zero kind of went out the opposite. But up here, it's pretty interesting. So peak is moving the point along the normal. So it's basically scaling the point along its normal. Um, and 0.001. And so I just wanted a little bit to puff it out a little bit, but not too much. And so 0.02. Okay. So peak. There we are. So that's what I started off with. And relative to the size of the cigarette, for the smoke, that's probably good. But so it's pushing out a little bit. And if I turn that off, that's what I got. And so maybe I didn't even need it at all, but it just makes the smoke slightly bigger with it turned on. And then I did a facet to post compute the normals, and maybe my normals were okay. And then that goes out to my renderer. So that's what gets rendered as a smoke. And that one too gets used the same shader. So I have the principal shader CD, and I also did another render with the normal shader, and I did the same exact compositing thing. So, okay, I'm done now talking about these two additional types of smoke renders that I did. And I've given you a whole bunch of different kind of smoke renders. I tried all these different methods. And this one here may be the best one. The other one that I showed earlier may be the best one. But I would definitely tweak if I was working in production. You can see I have this tendency. I want to keep on tweaking it and make it better. And these are comments that I'm making. These are comments that the supervisor may make. And it's tweaking the small details that often takes the most time. Setting up everything can get done like in a day. And tweaking the numbers of your setup could take several days or even weeks to try to get it to work right. And sometimes, if it's multiply, you change this one number on this one part of the object is going to affect everything else downstream. And so that's why effects can take so long and can be so expensive, is because it's tweaking the details to get things to look right. And then once I got this, then I send it off to render and I change my composite. And the nice thing about compositing in layers is that let's say I just had to re-render part of the smoke, but I don't have to re-render the cigarette. I just re-render the smoke, composite that over the existing renders of the cigarette, and I'm done. Uh, so this is the conclusion for the cigarette smoke. Everything that I showed you is going to apply to other projects. Now, in the normal listing of the projects for the Van S course is the volcano smoke. And so like the cigarette is like about what, 10 centimeters long, something like that, 8, I don't know, 10 centimeter, 12 for a cigarette. A volcano is going to be, just the width of the area where it emits can be 100 meters. So way, way bigger. And that's working at a much different scale. And you can see a lot of those numbers that I set inside there have to be different. So if we're working at a real scale for a volcano, which in some movies you have to work at that larger scale, your numbers are going to be just crazy different. And then sometimes a scene like that, they won't work 1-to-1. They'll maybe reduce everything down by 10. So the volcano is really only 1/10 of the size. Sometimes they'll reduce it down to 1/100th of it. But then everything in the shot then gets reduced down to either 1/10 or like 1/100th. Um, and and that's when adjusting your numbers become tweaky, because your numbers aren't going to scale as well. All these different noise parameters, adjustments, shader setting, things like that. Um, they don't, sometimes they scale relatively correct, but getting that relative number is tricky. Um, and so uh, another reason why the notebook works. So like the notebook is okay. This number works for real scale for a cigarette. If I use this for a volcano, which is at least a hundred times bigger, my numbers are all different. Okay, and uh, we'll leave it at that.